So in this lesson we will be given a graph or information about the graph, and then we have to find the equation. So let's review. If we have this equation, let's find the axis of symmetry, the focus, directrix, and vertex, which just means we graph it and then identify all those parts. So we know that 4p is 8, so p is 2. And we have left 2, up 1 for the vertex. We move horizontally because y is squared, so we're going to move horizontally 2 to get to the focus. That means we'll move left to the directrix, and the axis of symmetry. The axis of symmetry is right there. So, axis of symmetry is y equals 1. Vertex is -2, 1. Focus is 0, 1. Directrix is 1, 2, 3, 4. X equals -4. And pause the video and you try this one. X is squared, so it's going to open vertically. The vertex is, I need to change that. This should have a y plus 2. And it's going to open vertically. We're going to move right 2, down right 1, down 2. And that is the vertex. We're opening vertically, moving positively to the focus, so that means it'll be up here. With the axis of symmetry down there. So we have axis of symmetry is x equals 1. Vertex is 1, -2. Focus is 1, 0. Directrix 1, 2, 3, 4. Y equals -4. We have two problems here, and the easiest thing to do is just graph it and then look for the numbers to put into the formula. So let's graph it and then we'll see which formula we need to use. Vertex, -2, 0. Focus, -3, 0. If that's the vertex and that's the focus, the parabola must be opening like that. And there's the directrix. We don't need the directrix to write the equation. Since it's opening horizontally, we know we need a y squared, so it's y minus k squared equals 4p x minus h squared. K is the vertical shift. There's the vertex. It didn't move up or down, so the vertical shift is 0. 4 p. P is the distance and direction to the focus, so we moved left 1, and that will mean we have p of negative 1. H is the horizontal shift, and we moved negative 2. Oops, there's another mistake. That shouldn't be squared. So we can say it's y squared equals negative 4x plus 2. Okay, pause the video and try this one. Vertex, focus is over 2, up 1. And the directrix would be down here. We know that the parabola is opening upwards around the focus. So it's opening vertically. That means we need x minus h squared equals 4p y minus k. Horizontal shift of the vertex is 2. The vertical shift of the vertex is down 2. And P is the distance and direction to the focus. Here we move 1, 2, 3, so it's 3 there. So here we're going to have just have to deal with some fractions. Vertex 1, 2, 3, 1, 2, 3. Focus is over 3, down 9/4. So negative 9/4 is negative 2 and 1/4. We're going to go over 3 and down 2 and a fourth. If we go down 1/4 beyond negative 2, then this must be 3/4 right here. And the parabola is going like that. So we have it opening vertically. We need an x squared. 4p y minus the vertical shift. And we know that the vertex moved down 3 and the vertex moved right 3 with a positive vertical distance and direction of 3/4. And same type of question, pause the video and try that one. And just by looking at this, we'd have to really visualize it to see if it's opening vertically or horizontally, so we might as well just graph it. Focus. If that's the vertex and that's the focus, then it must be opening like that. We know it's opening horizontally, so that means we need a y squared 4p x minus the horizontal shift. The vertical shift is 1, horizontal shift is 2, and the distance to the focus is 1, 2, 3, 4 with a positive direction, so it's positive 4. And leave some space. I'll probably put another question there. All right, here's a different information about the graph. We will still just graph it and go from there. We have this 2318. Let's not draw it to scale. We know it'll be over 23 somewhere up there, and then the focus is focus, but we don't know where the vertex is, so we need the vertex to find the shift translations. If this is the focus, then we know that the distance from the focus to the point is the same as the distance from the point to wherever the directrix is. And so that's the directrix. We don't know where the directrix is, but we can find this distance, and then we can go that same distance to the directrix. If we know the focus and the directrix, then we can go halfway between that to find the vertex. If that's the directrix and that's the focus, then the vertex is halfway between. So let's start by finding this distance. And we have the 2 points, so we can do the distance formula or the Pythagorean theorem. So let's find the distance. The distance is x minus x squared plus y minus y squared, and we get 25. So that means if this is 25, then this is 25. We have this y value of 18. So if I just go from 18 down 25, then that will be the directrix. We have this point at 2318. Let's go down 25, and that will be 23, negative 7, because we subtracted 18 minus 25 gives us -7. Now we know where the directrix is. We know where the focus is. So we up 3, down 7, and that is the total distance between the focus and the directrix. That's 10, because we're going up 3, and we're also going down 7. This is 10. That means that halfway between that would be down 5 from there. So if we start at 3 and we go down 5, we'd be at -2. So the vertex is over 3 down 2. And then we can write the equation. It's opening upward. And we would say that we have an x squared 4p y minus something. And we're shifting up, right 3, down 2. This is the distance to the focus. We already saw that that's going to be a 5. So there's 5 there, and we're done. Try it again with a focus of 11,4, opens to the right, and it has a point 2016. Pause the video and try that one. (11,4) is the focus. It opens to the right, and the point is at 2016. The graph does not go through this point because that's the focus. The graph is going somewhere over here. We don't know where it goes, but that distance has to be equal to this distance, which is the distance to the directrix. So if we find this distance, then that'll be the same as that distance, and then we'll know where the directrix is like we did in the previous problem. So this distance, here we have 11,4, so we'll go x minus x, 11 minus 4, no, 11 minus 20, and then we'll go 4 minus 16 squared, and we have 15. So if this is 15, then this is 15. We know that the x value is 20, so by going back 15, then this should end at 5. And we know that the directrix is at x equals 5. If the focus is at 11 and the directrix is at 5, the vertex is halfway between there. This distance is 6, so we know that that distance is 3, and we know where the vertex is. The vertex is 3 beyond 5 and 3 before 11, so it's at 8, 4. And it's opening, oh, that's off. It's supposed to go through that point. It's opening horizontally, so we know we have y squared and the y value of the vertex is 4, the x value of the vertex is 8, and the distance to the focus is 3 we moved right, it's positive 3. I think we just have to do one more, so pause the video and try that one. Same question, find the equation. So the focus is at 1, 3. The point is at negative 14, 11. And the graph is going around like that. It's not going through the focus. We need to find the vertex. That distance needs to be equal to that distance, and that will give us the directrix. D, and we have the distance formula, x minus x, y minus y. All right, D is 17. That means starting from negative 14, we're going to move to the right 17. It's going to take us all the way to 3. We have 3 plus 14 is 17, so we know the directrix is at x equals 3. The focus is at 1, and that means that the vertex is halfway between. We go 1 to the left, 1 to the right, so that means we know where the vertex is. 2, 3, and the parabola goes through this point, through the vertex, and then back. You see it's opening to the left, and that means we need a y squared and the y value is 3, the x value is 2, and the distance to the focus is 1, but it's moving to the left, so the direction gives us a negative. And we'll stop there.